first new project. So as soon as you click on the mouse new project, it will open the new window. Now this software has an advantage that is available in graphical interface and also in command prompt also. So both method will learn. So this is graphical interface. First start the window with clicking new project. Now this is available space, plane, floor and truss. So definition of the space or written below that. Okay, what is that space that defined by the STAAD.PRO? A structure which is a three-dimensional frame structure with load applied in any plane is the most general. So that is your space. So that applicable all three basically fundamental axis x, y, z load can apply. Next is a plane. A plane structure is bound a global xy coordinate system with load in same plane. So what is that global? As soon as we move to that screen, I will tell you. The next is floor. Floor is a structure of a three-dimensional having no horizontal, in bracket global x or z. Movement of the structure fx, fz, and my restrained at every joint. This is just hint what is available over here. At the time of the discussion, it will tell by the teacher. And then truss. A truss is a structure consists of the member which can have only axial member force when it is acted on the node of the truss. So this is four basic available. Now beside that file name and location. So let's make the location. You can change. Now we are saving everything in short-term training program 12 September. Okay, now we'll name as this structure as beam. Okay, now for that we'll take as a plane determinant structure, that is statically determined structure. Now below that unit of configuration is given for length and force. So this is meter and kilonewton available metric system. You can change or switch over. So we are keeping as it is meter and kilonewton. Then I am allowing you to click that next button. Okay, the speed is okay. Okay, so next. Okay, so if this is already exists, so let's make that correction. Beam practice 1. Now next. Now what do you want to do? That is your new window. There are so many things is available. Add beam, add plate, add solid, and its definition is also below that available. So we'll jump to that add beam. Okay, now add beam. So begin building your model by creating a new joint and beam using the construction grid drawing and spreadsheet. So I am making this finish after clicking add beam. This is finished. Now this is your snapshot grid is available. Okay, so grid and snap node grid window is whatever you work is available on this right side of your pen, just below that. Now I am introduction. This is first line is file bar. Okay, this is file bar, and this is different tool is available by default of STAAD. And below that, below this tool, this is page control tab is available. Okay, you can switch over to different mode. At present we are in modeling mode. The modeling is most important part of this. Then below that status bar is available, and so what is the status? So We are in snap node, so this is add node slash beam to the line intersection using the cursor hold control. This line gives the instruction. Below that, so that coordinate is available x 10 according to your movement. This coordinate gets changed, and besides that, the unit is available. Okay. Now I am closing this and opening. Now this is your simple mode. We'll switch in later on. First, this node window to window is available. First is node beam practice 1, then window is node, then beam practice 1, then below that beam. So we'll start with that, applying the node. Let's with 0. Then next is, let's keep x as a 3 meter, y and z is 0. What is this axis over here? This is axis is called global axis. So this is according to right hand rules. This is 3 axis. This is x, this is y, and this is z. The finger pointing towards the positive direction. This is positive y, this is positive x, and this is positive z that is coming out of screen. Remember, this is global axis. There are two names. One will repeatedly come across, the global and local. So whatever you always found in screen, that is global. This is always available. This is very important. This is global coordinate axis.
Global coordinate axis is for whole structure.
Okay,
And local
so that is
axis
your
is for
according to
particular member of
left hand rules, like this. This is coming out of screen z, and this is x, and this is y, towards the positive direction, finger pointing towards the positive. So I have given 3 0 0. Okay, now that form these two nodes on the screen. Now I am moving to that next window, that is beam. Okay, now node A and node B. So in which the definition of beam is connection between two nodes. One is A and second is B. Now I am writing what is A node, that connect A as a one node and connect B as a second node. Now I am entering. Now you are found that connection. Now beam 1 is generated between node A as a one node and node B as a second node. Node A means starting of the beam and node B means ending of the beam. So beam defined between two nodes like that. Okay? So this is one approach to generate that beam. Now for analysis and design, as the Professor D.G. Panchal told you that it required. Now this is one window. You will automatically find, for backup will created or automatically save, you will find each and every 10 minutes. Auto save will save your file now. Do you want to proceed? Yes. And save. So it will automatically save each work after 15 minutes or 10 minutes, sorry. After 10 minutes automatically gets saved. Now this is beam. There is no property at all defined. If you want to do by matrix approach, or this software is based on this matrix approach, basically stiffness matrix approach, that is a fundamental. For what is that input for stiffness matrix method, for finding out at support, what will do it? Stiffness matrix What is requirement for finding out that generating shear force, bending moment diagram, displacement? And what is the requirement for by member approach? Stiffness matrix. It is stiffness matrix is formation of which material property? Which material property? E and I. Okay. So that is material property. E is modulus of elasticity and I is moment of inertia. So just like this software for basically inputting or finding out this generating that anything, it requires something input as a dummy. So we have to give as a dummy material property and section property, because I is depend on size of size of the section B and D. Okay, so as a input we have to give something as a material and modulus of elasticity. So now next step, go to command. Now onward write down command. Now first, then third is member property. In which I am clicking the prismatic. Okay. So it will open two windows simultaneously. Okay, one is property window and property for whole structure. Okay, there are two windows available. You can only operate first as a property window. Okay, so different property as a prismatic property we have opened. Do you know what is the prismatic? What is the prismatic? So along the length, the section is constant. It's just like a prism. Okay, so this prismatic section, first is circular. Then you can understand what is the circular. For defining this property, only the diameter is sufficient. And then below that material is also there. You can switch the material by dropping down steel, aluminum, concrete, like that. Okay. Next is a rectangular, T, trapezoidal, and in general. In general, you have to define that cross section along that X plane, Y plane, Z plane, moment of inertia, which is unknown. Property means that none of that circular, rectangular, T or trapezoidal. And for that anything you want to analyze, you have to give this input material. So let's we take one trial as a rectangular section. Okay, in rectangular section, first is available YD and this is ZD. This is depth along the Y and this is depth along Z. Okay. So first I give that YD as a 300. Unit is meter. For switching the unit, it is, you will find something, press F2 button for unit conversion. When you move to that window into tab, you will find that something written, press F2 for change of unit conversion. So now I am pressing F2. So current unit is in meter. It's window open. Please enter if you are done or editing. Please escape to cancel. Press Ctrl plus Q to see all available unit. Now in that window, please press Ctrl plus Q. Now you can find everything. This is kilometer, meter, mm, inch, feet, yard. Okay, so let's have a in mm. So how many mm? Let's have a that, that is 230 mm depth in z direction. Now after then just press enter. It is automatically converted into meter. Okay. Now just I am adding this property that get transfer into this property wall structure window. Okay. Now I am closing this window. Now this is your basic approach is you have to select the material from library, then you have to add into your project. This is now available, but this doesn't mean that this is assigned to this thing. Now the next step is for assigning this to our beam. Okay, so in this window the first is reference 1 is available, then section rectangular 0.3 by 0.23, and then material is concrete. In case of if you want to edit, double click, or after selecting this reference 1, press edit. It will open this window. In case of if you change the depth, instead of 300 to make that is 400, press change, you will find the change occur on your library. Now next it is essential to assign this thing to your beam. Okay, so I am selecting this. Now below that assignment method is available. So what is that assignment? Whatever you add in library, that should be need to assign this member, because this is your member approach. And for generating the stiffness metric, it is essential to have a set material section and its property, it's concrete. So below that assignment method is there. First is use cursor to assign. By default is available. For assigning this by use cursor to assign. Now next click into assign. Now as soon as you move to screen, your cursor get changed and you will find some property is there. This is your I section property. Now I am clicking on that beam that will assign, and you will find this is as a R1. Okay. Other method is assign to view. So if I select the assign to view and then I press assign, this will assign to view. View means whatever you have created in this beam practice whole structure window. Whatever you have created into this whole structure window, it will assign to that. But since this is your single beam, its view is only one thing, that is your one element beam, so it will assign automatically. Now next is assign to edit list, and one is assign to selected beam. Now look at to assign to selected beam. Now it is suppressed, not available. As soon as I click the beam, then you will find this is activated, assigned to selected beam. Means to activate the assignment, it need to have a selected beam into window. So if I select this window, if I select the window, I automatically find this option is activated, assigned to selected beam. Otherwise it is not available. So primary requirement of this assignment, you need to select something. So this is for different purpose, this different option is available. Okay. When we have a big structure like the truss and frame structure, At that time I will taught you in detail, because it's selected member, the section property is different. For that you have to assign by selecting that member and then assign. But small structure is not that much important. Now next is assign to edit list. You can edit because nothing is left, only one is there. You can write down in this tab 1, 2, 3. After giving the space you can write down, and then you can write down assign. But since there is no beam as 1, 2, 3 is available, you will not finding anything. But assign to edit list is like that. You have to click over here, then you have to add the beam number. Now this is beam number is not available. Now write down the shortcut for knowing that beam number. Uh, Keyboard shortcut for knowing the beam number, press Shift plus B. Shift plus B. B for beam. Click on screen and then press Shift plus B. That will note as a center. This is your beam number 1. Now for identification of the node or knowing that node, press Shift plus N. That is your keyboard shortcut. So it will toggle on and off. If you repeatedly press, first press it will show and second press it will get or the display was removed. First press it will show and second press Shift N it will remove that show. Just like that beam. First press it will show that beam number, then second press Shift plus B it will remove. Now as soon as I move this beam, you will find, let me go, this is view is isometric view. Okay. So we'll change as a front view. So next is view, click on view. Okay, the first shortcut is over here, the tool is available. This is your isometric view. The next is, this is view from negative y-axis from bottom. This is next is, as soon as I move this my cursor you will find positive y. And this is your positive z. Positive z means you are watching from this axis. Positive z. This is positive x. This is positive y. That other to that axis, that is other direction. So first this is your view from positive x. I am clicking. This is now as a elevation or front view. Now look at this effect. If I go to nearer the beam, that is magnetic effect, you will find 3 color. One is green, other is red, and third and next is blue. So green color indicate, write down the green color indicate the beam with starting node is highlighted with green color. The ending ending node of the beam is highlighted with blue color. And the central portion of the beam as a red color. That is three part of the beam. Now I am changing and not showing. You can change this node by simply writing over here one node as a 300 300 and next is 000. Now I am clicking again, the color is get changed. Now look at that, blue is green and green is blue. You have observed? Now let me change that. Now carefully note down, the blue is left of your sitting and right is green. Now I am changing the incidence. For changing the incidence, I am moving to this window, that is node window. I am over here writing down 0, then 3, like that. Now I am moving to this. This is get changed. Now why this is important? The green and blue color, the sum of the load in your load, that is just like a partial UDL. It will start assigning on the beam from starting of the beam node. That's why it is important you know that the starting of your beam node, because some partial UDL is there, means that only that at central portion is there. So it is away from this corner as a 1 meter, and it is away from that corner is 0.5 meter. So how will you define? So in that, for assigning such a partial load, it is essential you know that where it is starting node and ending node is located. Okay. Now this is a beam. We have assigned the property. Now what is the next for anything support, restrainment or constrainment? So let's move to that command. Write down command. Support specification. I am clicking on pin. It will open as new window as a create support. So simultaneously open support for whole structure, that is for your library. In library only one is available, there is no support is available as one. And this is create support window. After creating one, if you click as a add, that will add to your library. Okay. Now what is the support condition? First, that is pin. So what is that restrainment? It will not allow you to displace in Fx, Fy and Fz. In other words, it can produce the reaction only this direction. This is by default 3 directional pin. દેખાય છે ને તમને બધાને? બહુ જ આખું દેખાય છે. લાઈટો બંધ કરીશું તો સોરી. Option available नहीं zoom in zoom out है. આ સેશનમાં ચલાવી લો, નેક્સ્ટ સેશનમાં ફાઇન ટ્યુન કરીને સેટ કરવાની કોશિશ કરીએ. બરાબર. Now we are in command member support specification. Now I have click on pin. Now it will open simultaneously two window. One support as a whole structure, that is your for library purpose, and in general what is the support. Now in support, create support window, there are so many support is available. First I have click on pin. So what is that pin? That is only that is generate the reaction in particular fx, fy and fz, and unable to take, that is moment. So you can tell this support as a three-dimensional hinge support. Next, this is your fix. I am clicking on fix. So this is restrain everything. Do not allow you to deflect or rotate the beam at that x plane, z plane and y plane. Now what is that moment mx, my? Again this is your this left hand rules. So moment mx means that rotation along this x axis clockwise. This is mx. My is like that, and mz along this like this. So this is three rotation. Understand? Just like that axis, clockwise, positive. The other support is fixed butt. What is that? You can define fixed butt, but what is that release? And also you can define the partial releasement. So you can give that spring support after providing the stiffness along that x, y, z, and the rotational spring is also possible over here. Stiffness per unit rotation is also. This is same for generating semi-rigid or complete rigid up to certain limit. That joint provide that fixity and then it start deflecting or rotating. Next is enforce, just like a fixed support. Enforce is nothing but that fixed support. There is no difference at all. You will find the restraint fx, fy, fz, mx, my, mz completely fixed. And just like that, enforce butt. Enforce butt, in what direction you like to have restraint or release. Means if I click the release fx, then it will show the displacement along that plane, or it will not offer the resistance along that plane, x direction, and it get released. And this is enforce. All are enforce. fy, fz, mx, my, mz is enforce, but release fx only, like that. This interpretation is like that, just like a fixed butt. And this is multilinear spring, and this is only you can assign. Over here the knot is written. This support requires that earlier assignment of a spring support to the node to which this support would be assigned. This is at this level none of the use. Then foundation and incline is available. Okay, just like so. Now I am clicking on pin and just adding that. What is that pin? So this is get added over here. Now this is one support I am keeping as a pin and other as a roller, making that complete static determinant structure. Now for adding the other support, just move to that create window. create window. I am clicking that create window. Again it will open as a create support window. Now nothing like a roller support is over here. So I am making from out of enforce, but in roller it produces only reaction in which direction? Perpendicular to y plane. If my loading is along the y plane, it should produce the reaction only on y plane. So I am releasing fx, fz, mx, my and mz. Only is capable to produce the reaction in y direction. So this is your classical roller support for vertical loading or gravitational loading. So I am just adding.
Or otherwise you can assign both the ends as hinged also, as it is taking only vertical loads, it will have only vertical reaction.
Only vertical reaction. That is also possible. Okay. Now this is support is available in this your library. Now next is assignment. Just like a previous assignment, there are 4 assignment method is available: assign to selected node, assign to view, use cursor to assign. So different node, I have a different requirement. At node A, what is that node A? I am pressing shift N. At node A, I am wanting that hinge support, so I am selecting S2. Now this is use cursor to assign is by default selected. Now I am clicking on assign. Now I am moving to my screen, my cursor gets changed, and just like a of hinge support is available. Now this is I have assigned. Now I am moving to that support as a whole structure. I am selecting S3 support as a roller. Now I am clicking assigning, and I am moving. Will find the support is like this. Now this is assigned. Understand? So what is that assignment? Whatever available in your library, first select that. As soon as you select this, you will highlight as a blue color, and then move to assignment method. By default, use cursor to assign is available. So for activating this, you need to press assign button. So as soon as you press assign button, now it is changed to assigning, and then move to your screen. You will find this is support. Now I am assigning again as a support 2. Okay. So in case of that change, I am again selecting S3 and assigning is available. Now I am moving on the screen and clicking again S2. So this approach, by doing this, it will overwrite or delete that previous assignment support. Overwrite means it will delete the previous assignment assigned support, and new is click as a ruler support, or release only on FY. So this is your ruler support. Now I am closing this. Next is I am adding that load.
Okay. The geometry is over. Geometry, after preparing the geometry, he has given the material property for the beam, then the supports. Now we are going to give the loading, right? And then after it will be analyzed and then designed.
Okay. Now I am moving into again command. Now loading command. Next is loading. I am switching to that primary load. clicking the primary load will open again two window. Okay, one window has a primary create new definition slash load case or slash load item. So this window, and this window at a right side of me or you, then this is your load and definition window is available. So first is operatable, first window has a green color only. So first is number, that is by default 1 is available. This is very important, loading type, and that is you can select by drop down. This is very important in case of automatic load combination. So I am going to dropping down, there are different loading criteria and type is available. First, day live, roof live, wind, seismic, snow, rust, fluid, then soil, rainwater, then ponding, dust, traffic, lot of is available. Last is none. And push, gravity, mass, crank hook, wind on ice, flood. As per our code, that's defined, that is date. And this is your title that will display in your load and definition window. So I am rectifying this load case 1. Instead of load case 1, I am writing
DL.
capital DL.
Normally we are denoting dead load as DL.
DL. Okay. Now I am just clicking on add. Okay. Now let me one thing. In each of this window, you will find 3 tabs. That is add, close, and help only. First is add, then next is close, and then help. Now I am clicking on add. So you will find that is added into load case detail. That is added into load case detail. Just as a name, but nothing. What is the dead load? So there are so many kind of the dead load. For going that particular criteria, I am clicking on dead load and just pressing add. Very important. This is just name. Nothing is added. This is just name. Now this another window will open.
Dead load ને select કરીને add ઉપર click કરવાનું એટલે આ window open થાય.
Select dead load and then press add again. So it will open the different. So depending upon that, the first is self-aid, then nodal load. It is act only at nodal. Next is member load. This is member is nothing but your beam. It's act on member. The next is physical member load. Then next area. So I am clicking at nodal. There are sub parties also there. First is node. At node, what is fx, fy, fz, mx, my, mz, you can define and add. And as a support displacement, you can also add as a load at a node. Then member load. So what is that? Uniform force means UDL, uniform moment, that is uniform moment per meter run, like that. You have not learned, but this is also possible. The concentrated force means point load. Then concentrated moment. Then UVL, linear varying load. That is your triangular, there are shape is available. Then trapezoidal, okay, W1, W2 is different. Then hydrostatic, Okay,
retaining wall पर ना है.
this is your different geometric load. This is next is pre and post stress load. So pre stressing and post stressing force you can add as a load. Okay, or for the different geometry, that eccentricity at start, middle and end is also there, and that is fixed and load. This is you can assign on a member. Okay, so first this is uniform force, just one first. So in uniform force, this graphic is given to you. Okay, what is W1? That is red mark. You have to define the intensity W1. First, that is D1. What is the D1 distance?
Starting of UDL.
Starting of UDL from starting node. It is clear, that is starting of UDL from starting node. And D2 is ending of UDL with the starting node. Always from starting node. And D3, it is out of axis, then you have to specify D3. Now interesting that if you don't give anything as a D1, D2, D3, it will by default assign to whole beam. By default, remember. Now intensity, it is over here kilonewton per meter. Let's have a specify 10. Now over here the direction is given, that is GY global Y. Okay, this positive means global Y means positive means this is what my finger pointing towards the positive direction. The load is acting with the gravity, and that should be always negative, not a towards the positive valve but downward. So please remember, in loading window you have to enter load as a negative. It is, though our direction is given below that x, y, z local we'll discuss later. This is global gx, gy, and this is px as a physical member, px, py, pz. So first global y direction load is there. You can apply the load along the global gx, gz also. This minus indicate it is downward. Okay, I'm not giving anything. Below that, add, close and help tab is available. You are not visualizing on screen. I'm just adding. You will find that add uni gy 10 kilonewton per meter. I am press add. You are not visualizing this add button over here. So this is your uni gy 10. Now before that you are finding some question mark. Okay, so this question mark indicate this is in your library but it is not assigned to anything. Now I want to assign. Now again that one approach. Now let's move to that other approach, assign to view. In view only one beam is available. It will assign to this beam. So I am selecting this assign to view, then pressing assign. So it will give you that other window. The assignment method you have chosen is assign to view. Do you want to proceed? Yes. So you will find
Now it has changed to blue one, green one.
green.
Once you have assigned it, that question mark, red question mark has gone away, and the green
Look at over here.
means it is assigned now.
Two boxes available from at the last line. It is not quite clearly visible. This is two boxes available. Neither one is question mark, means it is showing that is load is assigned. Now that screen of load is out of your visualization. For checking,
So we can change the scale of loading.
scale of loading is out of your this window limit. So you can change, write down that for changing that
Change of scale.
change of, change of loading scale. So go to view, then structure diagram,
Scales.
and then scales. The tab is top available. Okay, this is your scale. Okay, so in this window at the right side, one checkbox is available for immediate action. Apply immediately.
એની ઉપર ક્લિક નહીં કરો તો ચેન્જ નહીં થાય.
One checkbox is available for next. If you not make this checkbox okay, then your next addition in this structure, it will get changed. But the available is not get changed. So applied immediate effect is necessary to make as a check. Okay. So don't forget to click on applied immediately checkbox. Now there are different is available. What is the load scale? This is load scale and this is result scale. Our is a load scale and that is distance force. Okay, that is kilonewton per meter. The scale is 5. I am reducing, not finding, I am increasing. Okay, now it is available in screen. Now that value is also not available on screen. So next to this scale tab is next tab is load and result tab. Okay, now that is available on label. Sorry.
So everything whatever you want to display on the screen, that can be done with this window, right? From view menu we have gone to structure diagrams, and then from structure diagrams these are the tabs. So first we have done with the scale, and now labels.
Okay. Now first I have given to you that keyboard shortcut, that is shift. So below that end of this, look at this tab. It is visible.
The practice hours માં તમે ખોલી ખોલીને બધું જોજો.
બહુ જ ખરાબ દેખાય છે આમાં.
એટલે આમાં બધા શોર્ટ વિન્ડોઝ લખ્યા છે એટલે તમે
દેખાતું નથી ને તમને પાછળથી?
એટલે જે લેટર્સ બતાવે છે ને બ્રેકેટમાં શિફ્ટ સાથે એ લેટર દબાવો એટલે એ વસ્તુ તમને ડિસ્પ્લે કરે ડાયરેક્ટલી. આપણે શું કરવાનું છે?
આને ચેન્જ કરાવવું પડશે હવે. બહુ જ ખરાબ થતું જાય છે જેમ જેમ અવર્સ થાય છે ને
એ બાજુ વધારે છે. આ બાજુ સારું છે. આ બાજુ લઈ લો ને વિન્ડોઝ
એટલે બકુલભાઈને આપણે બોલાવો સર્વિસ.
લોડિંગ.
Okay, now this is your label tab. I am clicking. First I have told you that shift N and B. Where is there? Why have I told you that? This is written over here at that end. Okay, for the quick access to that label using that keyboard hotkey, press shift plus the letter shown in the parenthesis. Okay, is in bracket is it available. Okay, so load value. So if I press OK checkbox over here and then press as I apply, you will find something written over here. Or in other word, rather opening this window, diagram window, if I press shift plus V, that will display value. just like as a beam numbers. So shift plus B, okay. Then node, shift plus N, okay. So I'm applying, then pressing OK. Okay, now I'm pressing shift V, it will toggle to gone away, and again shift V, it will display 10 kilonewton per meter. Now this beam is loaded with UDL. Now next is essential command. Next is essential command. Write down, very important. Go to command. The next is analysis. And go to perform analysis. So if I click, I'm again going to that command. Just below that loading analysis is there. Perform analysis, then perform analysis. I'm clicking on perform analysis command. So it will open the perform analysis window. And this is your printing option is available. What do you like to have at the output? No or load data, static check means that sum of force resolve in horizontal vertical plane, H, V, and sum of the moment is 0. That is a static check. And then static load, only static load, other than dynamic load that like earthquake. Mode shape in that is in dynamic analysis available, or both.
All करतो तो બધું મળશે.
And that is your all. So let's keep as a printing option as a output all. It doesn't make any processing time of this analysis. It doesn't affect on processing time. It will just show as a output window. I will later on show you. I'm just pressing after selecting all printing option now as OK. Now this is I have just given the command. Now for running that analysis engine, just move to analyze. Just press run analysis, or from screen shortcut is available, control plus F5.
તમને લખવામાં અંધારું પડતું હોય પાછળની લાઈટ કરો ચાલુ. ના પાડે.
લાઇટ બંધ કરી તો સારું દેખાય છે તમને કે પહેલા કરતા સારું દેખાય? Okay, I am just pressing the analysis. So before that, each of that analysis command you will find warning window. Structure has been modified. You like to have? Yes, I want to change. So I am pressing save. So it will make such a procedure as long as this like that. So what has this STAAD has proceeded? This has generated process, joint coordinate, then member information, then member property, then reading that member property, then processing.
The process of analyzing.
And how much time it is taken? It is 1.42 second only. Now what is that view? This is 3 tab is available, radio button. Go to post processing mode, stay in modeling mode, or let's keep as stay in modeling mode, and I'm just pressing on done.
Zero error, zero warning.
This is also essential. error and warning, it will show you. For editing error and warning, you need to go to view output file. So click on view output file and just press OK. So we'll open, this is output, total apply load and total reaction. Again I am clicking what is that different mode. Just I am analyzing again, and I am going to keeping as a stay as a modeling mode. Just done. It doesn't show it is available. Now you can switch this modeling mode to processing mode. Now I am going to post processing mode. Okay. Now I am closing this window. What is post processing? That after your analysis, what is that available, you can check this. I am just closing. Okay. Over here, one toolbar is available over here. That is your fx, fy, fz, mx, mz, my, mz. This is
કલર બી આપેલા છે. રેડ કલર છે, વાય માટે છે.
so one by, if I click that fx, it will generate, if available, then it show that axial force diagram over here. Fy, that is shear force diagram. I'm just closing this. Then fz, that is again, that is your fz. What is that? That is perpendicular to beam axis. Again, in shear in z direction, fz. Axial force diagram, along that y direction shear force diagram, along that z direction shear force diagram, and axial force diagram. So there is no load, because there is no load, so diagram is not there. I am off, making off. Next is mx. There is nothing, is mx.
શું આવશે? my આવશે, mz આવશે, શું આવશે?
So this is your beam axis. Okay, this is your mz. So let's click at mz. Mz is available. Understand? This is bending along this axis. It is bend this axis. So rotation along this z direction, beam bend like that. This moment is rotation along the z axis, about z axis. So this is mz. So my, there is nothing, and mx, there is nothing, because for bending in mx, so in this direction, if I want to bend like that, what should be the load? Along the z axis, the load should be there, and then it will bend like this. So this is your bending moment diagram, or this is also available through page control tab. There are three. First is from this tool. Next method is from result. In result, that is beam bending moment. I am clicking beam bending moment. It will show this diagram. Again go to result, deflection. So let me off this all. Result, this is deflection. So scale is not there, you have to change the scale, same approach. Go to view, then structure diagram,
loads and results.
okay. So this is result scale. This is bending Y, bending Z, shear Y, shear Z, axial, torsion and displacement. Apply immediately. I'm changing, just closing this. Result, deflection is on. Now view structure diagram, scale and then displacement. Make this checkbox, otherwise you will not find instant change. Now showing that deflection.
1 mm per meter.
Okay. I'm applying, then now OK. Now this is nothing, is value is available. For result, again for viewing the value. Okay, so view value. Go to result. Then click on view value. Okay. So what is that value? So that is for beam result. Okay. Of displacement, maximum resultant displacement. Okay. As soon as I make as a checkbox OK, it will, one tab is activated below, that is annotate. So I am just clicking annotate. It will slow the deflection on 394.
Now you can check with your analysis which you have studied, right? For simply supported beam with UDL, what should be the deflection? That you can verify.
So there's a deflection.
5W for what? So it will be. So that is why we have started with the simple beam, so that you can verify.
It requires the check, or you, let's make that check whether
Bending moment also you can check it WX square by 8. So easily you can verify.
I am writing over here equation, that is 5 by 384 multiply by
Bracket
what is that, multiply by W L raised to 4. So L raised to 4 means 1, 2, 3, 4. 10,000. Then so that is W into 5 by 384 into W. Then L raised to 4. And let's make that is 81. Okay. Divided by E. So E you are not knowing. So let's check what is that E. Now this is your parallel. Okay, this is your graphical interface, and same is available. I have told you before starting this software. This is command prompt is all also available. I am clicking on just STAAD editor, or other word, I am checking that property for that command, then material constant and elasticity. Okay. Concrete, it will not show over here. I have to click on table. So command, material constant, and then material table. I'm just closing. For checking that property, just click on command, then material constant, then material table.
Which values the STAAD is taking? Those values are available in the table. For steel modulus of elasticity, you can see 205 kilonewton per millimeter square. Right.
So this is for
For
concrete is
21.718
kilonewton per meter square.
millimeter square.
Per millimeter square, sorry, kilonewton per millimeter square. Okay, so this is 21718, 21.718. Two one kilonewton 718. Okay, so that is in Newton. Our load was in kilonewton or Newton, so that is 21.718. Or now it is per mm square, so what is that? Multiply by 1 2 3 4 5 6. Now still, then I. So multiply by or divided by B. What is that width? Let's check it first.
Cross
Now
section do आप 0.45 by 0.23.
command, then member property, and I am clicking the prismatic, and I am closing this thing. Now what is that you have assigned? I am clicking that, you will find where it is assigned. So that is 0.40 and 0.423.
By 12. 0.23 into
0.23
into 0.43 by 12.
Now what is that? Where you have kilonewton? Yes. हाँ. Okay. So what is that mistake?
फाइव बाई थ्री एटी फोर છે ને પણ બ્રેકેટ આવશે.
Now this is in meter. Okay. Now check it, the deflection, result, view value, beam result, and maximum resultant, and anode.
0.39.
That is in mm. So 0.394. Now this is 1, 2, 3, 5, 4, and 6. Enter. This is in meter. Now this multiplied by 1000, that is given millimeter. 395.
394 આવે છે આમાં 395.
Okay, so this is correct. Let's change what is that effect of the available pin support. So for this advantage of this software, I am just changing this support. Okay, so first there I am going to that command, then support, and again pin support. I am closing this window. We have already pin support is available. This has a support too. Okay, I am selecting this, then I am using that cursor to assign, use cursor to assign. Now I am pressing assigning. Now my cursor is get changed. Now after analyzing the structure, if you make any change, we will find same window as a warning. You have made a change to the structure. As a result of this, the post-processing result will no longer be available. Means that deflection, support like that. In case of if you made the change, it will disappear. You understand that? That is depend on support restraint. That's why it is not available. Do you want to delete this result file? Yeah. So I am pressing yes. Now for again quickly analyzing, no need to give the again command, just times you have to give that analyze and run analysis, and then press save. Then stay on modeling mode, done. Then move to post processing, close this window, and go to result, view value, and beam result and maximum resultant anode. So what is that advantage of that pin support? Just like a act as a roller support. Understand?
No difference.
So both hand, if I give that, are you observing, or there are no horizontal reaction because there is no horizontal load on the beam. So if I give both as a roller support or both as a pin support, the ultimate deflection is the same. Okay. Now similarly, the other one method is to looking that shear force bending moment diagram. This is your tool. The other is this page control tab. Okay. For beam, this is modeling. Just click on beam. Okay. And beam, that is your beam force, then stress and graph. Okay. Now I am clicking on graph. So that bending moment shear force is available over here. Okay. So this graph is available. So first is MZ, second is FY, so shear in Y plane, and then FX. So MZ is bending with maximum bending moment is like that. Or other way, I am closing this graph, maximizing this screen and just clicking to MZ and then pressing off deflection. MZ. Okay. And now moving to result, view value, beam result and bending, that is and maximum midpoint anode.
Seconds, 0,
So
0.
what is that maximum bending moment? Let's check. That is equal to W, that is 10, L is L square, that is 9 divided by 8, 11.25. 11.25 kilonewton into meter. So this is so easily you can change. So this is one approach of the graphical interface. Now this is you can parallelly do by command prompt also. Okay? So now click on edit. I am introducing that non-graphical interface. Click on edit, and this is edit input command file. Just click on edit input command file, you will find this thing written. So first line was that now flashback your memory. After clicking the new project, you will find the next window type of structure, plane, truss, floor, in which I have selected the plane structure. So that is STAAD plane. I have not given any job information, so this is a practice session not available. In case of I have given the job information, you will find that like that. So start job information 12 September 11, end of job information, only this is available. Now input width 79, so up to 79 character it will show in one line. This is 1, 2, 3, 4, 5 input, like 79 character it will show in one line, then next is in next line. Next is unit, that is in length unit is in meter, and that is next force is in kilonewton. Okay.
This is what we have already given to the
Structure. So they have written that command file. Next is joint coordinates. So what is that joint coordinate? 1, that is 0, 0, 0 and then semicolon. So that indicates the joint 1 as a coordinate 0x, 0y, 0z. Next is joint 2 has a coordinate x3, y0, z0. Now if I want to add one thing, I am adding the next, that is node 3 space, it is located at a 4 meter, is next coordinate y is 0, z is also 0, then semicolon.
So 4 is from node number 1, right? So between 2 and 3 there will be only 1 meter. Got it?
Means this is your absolute coordinating system. Okay, 300, 400 means from it is reference to
Origin.
00, not a relative, not one relation to second coordinate. Means that it is from second coordinate, the relative coordinate will be 100.
If you want to keep 3 meter panels, then it should be 6.
600.
Instead of 4, it should be 6.
This is absolute coordinate.
6 color.
So let's make as a 6. So this is joint coordinate command, that is 1, 2, 3. The next is member incidence. So what is that member incidence? Member 1 is get connected node A as a 1, node B as a 2.
હવે બીજું beam બનાવવું હોય તો we should write down
Now I want to add the next.
2, 3.
So next beam number is second. Okay. Then 2, 3 and semicolon. So that means that member incidence command have added, okay, member second that is connected between 2 and 3 node. Okay. Now next is define material start, and next is isotropic concrete has a property E is written like that. So that is we have checked 2.17 1718. Poisson's ratio 0.17, density 235616. That is we have selected from by default material property. So what is that? It is written density, alpha, damping ratio, and this is your end of material property. Next is member property. Okay, member property first, that is your prismatic section whose YD and YD is 0.4 and ZD is 0.23. Okay.
And then 2 કરવું હોય તો
Now in case of if you want to change that YD as a 0.35, now other constant, this is constant and material concrete all. So whatever available we have used that assignment method as a view. So it is written concrete all. Or in other word, if it is I have given that by assigning to particular member, so it will write over here member 1 or member 2 like that. So this is material concrete to all, means whatever we have selected member 1 and 2, it is automatically assigned as a all. Then support 1 and 2 we have changed as a pin.
3 પણ કરતા હતા.
So let's make that 3.
Space નહીં.
So after giving that, there is no specific rules how much space you leave, but you have to leave. Now write down that few word about this graphic non-graphical interface. There are 3 color you are clearly visualizing on screen. The red color is a command line. The blue color is indicate input value. And black color, this is none of the execution, this is just as a text value it will show. As a text value, only text value. There is nothing, if you remove or add, it doesn't make any difference to any execution command. So this is red and blue is only important. Now next is a load 1, load type as a dead. Dead is this category type and title as a dead L. So if I want to change as a dead 111, it will show at dead 1111 in your input. So member load, that is 1, member load 1, that is uniform force. For that this is command is UNE. It is assigned to global Y minus 10. So 1, this is assigned to which member? So now I am making 1 and 2. This is assigned to member 1 and 2. Then perform analysis, print all and finish. Now this is, I have made the change. I am just closing. It will ask, do you want to save? Yes.
One more.
So now this is beam is get changed and one beam is get extended.
Editor file cannot be minimized. It has to be closed. Otherwise, whatever you make change over there will not be reflected in that editor file. So it has to be checked. You cannot minimize it.
Now this is some indeterminate. Now let's check it whether we have assign is there. So support is, you can clearly, I am clicking on this view as a front. Okay. So first let's check the support is clearly visible. Everything is a pin. Okay. Now let's check the material property. I am clicking material property prismatic. It will open 2 window. I am closing 1. Now checking to that whether it is assigned or not. I am selecting this reference 1. Now this property is only assigned to one member. Okay. Now I am closing this property window. Next is the loading. So I am again clicking command loading and I am primary load. I am just closing this window. Now I am clicking on load case detail. Now you are finding something written DL111. That is changed. Now I am clicking on this load. As soon as you click in this load, you will find the blue color. This is throughout on that member. Now that's where you are not finding that material properties assigned to that member. Let's go to again to editor. Okay. Okay. Now I am analyzing what give that error.
So here we know that we have not assigned the material property to the second part. Now you can see what errors or warnings it is giving.
It will generate the warning. Let's find out what is that. So one error. So what is that? One error, and now this is radio button is view output file. Error in analysis check output file .anl file. So I am clicking done. So now this is moved to that output file. Now this is your error, and what is that error? Section property not enter for member 2. It's clearly written. No, section property is not written.
So it will not analyze because there is no material property given to that.
So there is no stiffness metric for member second. So it will not show any result at all. So that's why this is error. So let's go into edit file, edit input command file again.
Or you can directly add it through the.
So this is member property. I am moving or highlighting this thing. Member property. Okay. First line is 1. That is assigned to member 1. Then next is 2. Then I am giving the space. Now I am closing. Then it will again ask save the change to the beam practice 1 STD. Yes. Yes, this is your chain. Now I am again analyzing and finding whether it is rectified or not. Now this is 0 error 0 1. Now for that you can check that deflection or over here axial force. This is your shear force. Y is Fy is shear force. I am closing shear force. There is no axial force, so I am closing that. Now there is no shear in Z plane also. Now bending or torsion. Now I am clicking on MX. MX. This is your torsion in X, torsion in Y, and that is bending in Z. So you are finding that diagram.
So we have studied simply supported beam to span continuous beam.
Now for viewing that value, go to post processing. Result, view value. Beam result, that bending and maximum midpoint, anode. Now this diagram is not clearly, so what is that? The scale you want to change. So the other option is available for changing the scale. Just click on right of your mouse, right click of mouse. There are so many options is available. So that is one is structure diagram. Okay, this is another directly structure diagram, or the from that file bar this is view and structural diagram. And in which scale? Now this is scale of result of bending Z. Apply. Now this is bending moment. Now I'm closing, and shear force like that on Y plane you can check it and view that result. Shear and maximum and mid anode. Okay. Close, and if the scale is not there like proper, right click of mouse, go to structure diagram, go to scale, and scale of shear Y, apply immediately and increase the scale, sorry, decrease the scale. Okay, apply, okay. Hmm? Hello, हाँ हाँ हम्म, Patel, તું ફોર્મેટ લખીને લાવજે, હું સહી કરી આપીશ. તું મને પછી વાત કર, હું અત્યારે લેક્ચરમાં છું, બરાબર? હલો, પછી વાત કરું, હું લેક્ચરમાં છું અત્યારે. પછી તું અહીંયા કોલેજમાં આવીને વાત કરજે 1 થી 2 માં, બરાબર? પછી ઓકે, હું અત્યારે લેક્ચર. Now this is your only that. Now this is your only UDL. There are so many load is available. Just I am changing this load or making that combination of that load. So again going that command, this is one approach, loading, and primary load, it will open 2 window. I'm just closing this window of, and then clicking that load case detail at date 11 in which only UDL is available. This is one approach. I am just closing that. Other approach is through page control tab. Over here the different tab is available. So in which I am clicking the general. Okay, in general, load and definition is by default is click. So in case of I click the load and definition, it will open another window at right side of you. Same window with load case detail and del load. Now I want to edit this load or remove this load. So double click this load, and over here the checkbox is available. So I am removing that, checking whether it is assigned to 1 and 2, and I am applying the change. So it will ask, you have made a change to the structure as a result of the post-processing. Result will no longer be available. Do you want to delete the result file? Yes. Close. So this is unassigned load. Now I am adding into this DL. So I am moving that to DL. Again pressing that add. So it will open this load window. Okay, load window in which member load. Now uniform force, now move to that concentrated force. So concentrated force, this graphic shows that there are 2 distances available, D1 and D2. So both beam of length of how much long that beam is? 3 meter. Okay, so at the center of I want to place this load. So that load is 10 kilonewton plus minus. If it is downward, then it is essentially minus. Now at the center, so D1, what is that? The orientation of this concentrated load from starting node of beam. So, and D2 is eccentricity through the axis of the beam. Beam width is 230. So it is a center of 230 means at a 115 this load is pointed. But if it is eccentric about its width, then the D2 distance is available. Okay. Our load is not as such. Now below that you are not finding anything, but over here add, close and help window is available. I'm just pressing add, you are finding this is add unassigned load. I'm selecting this load. Now using the cursor to assign, for that you need to press again assign. Now I am pressing assign, that change to assigning. Now my cursor is get changed, but nothing is selected over here. First select this thing, any of the load which you want to assign. This is load concentrated GY10 1.5 kilonewton per meter, assigning at a beam 1. Again the scaling problem is there, you can change. Next I am moving to that UDL, that is I am assigning to use cursor to assign, assigning is there, now UDL. So now I am changing, right click of your mouse on screen, structure diagram, scale. There is scale of load scale of point force. 10 kilonewton per meter downward. Apply, OK. Now in dead load category, I want to apply something axial load. I'm just adding as a member load how will you apply the axial load or concentrated load. So this concentrated load is available in GX, CY, GZ. GX. Okay, let's specify the distance towards the GX at node member 1 positive direction. So that is 10. Let's keep as a, this is at a 1 meter. Just adding, checking that whether it is add or not. This is added. I'm closing this window, now selecting this. Now this is by default use cursor to assign is selected. Assign. Now I am adding this. At 1 meter you will find this. Now there is horizontal load and gravitational both load. Now I am again analyzing this structure. Everything is there, just we have changed the certain loading thing. Command or run. Analyze, run analysis. Okay. Now this is over. The results straight up. I am closing this, maximizing, and now you can check that through this tool axial force is available for the member 1. Now you are finding something different in shear force diagram at a concentrated load. In theoretical analysis at concentrated load, what is that shear force diagram characteristic? Over here, whenever you find the shear force at a concentrated load, what is the characteristics of diagram? That is vertical drop. This is incline. So instead it is considered the load at a shearing calculation is next to next point as a least, this is your 1/12 of the section it considered the load. 1, 2, 3, 4, 5, 6 and this is other 6. because this is at center, so other 6 is other end. So load is considered 1/6 of that. So next diagram you will find like that. But that though this value is, you will find theoretically correct one. Graphically you will face that problem like this. The diagram somewhat inclined at this location. That is one limitation of this. Now you understand this beam analysis and like that. Now I continue this beam analysis, then convert it into portal frame in next lecture. Now if I do you like to have one practice session for this beam, or I can continue next lecture? That is depend on you, because our aim is to you want to learn this software. Okay? Our aim is everybody get aware about this software. So may I continue with that next lecture with portal frame, or you have a one practice session? Hey, that will be extra hour also I will take, but for this, at least this portion of this, that is very important of modeling part. Assigning that support, adding node, this thing is become very difficult as we move at the next lecture. So let's have a 1 hour of the practice session after this. Only 1 hour, not more than that. I will give the one problem, and for that you have to find out shear force and bending moment as a continue. So at least you get aware about how the software is work. So your confidence levels then after it will little bit higher when you come and do next lecture. Then we'll make that continuous lecture. Then on. So after lunch there will be one practice section only of 1 hour. Only of 1 hour. આ સ્પીડ બરાબર છે ને? હા હા. એક મિનિટ વિષય ફોટો. હા બોલો સાહેબ.
I love my family. Oi, full power.
પેલામાં જે બસ લાઈન હતી અત્યારે વિઝ્યુલાઇઝેશનમાં પ્રોબ્લેમ થાય પાછી ઓછી તો ખરું જ ને. બહુ બ્લડ નીકળ આવે છે. અત્યારે તો અમે તો લેક્ચર હતો, અમે હમણાં તો એવું હોય તો 1.5 કલાક નો અમે બ્રેક આવી જઈએ, કારણ કે પછી મજા આવે. એ દરમિયાન આરામ કરી શકો તો સારું. તમારી સાઈડ હા હા. આ તો તમારી સાઈડનો પ્રોબ્લેમ હોય તો જોઈ લો ને, ખાલી આ તો લેક્ચર નતા કરતા. પાછળ ઉભા રહો
એમ નહીં રાઈટ સાઈડ નું ધાકું દેખાય એમ નહીં
જો તો પાછળથી જો સ્ક્રીન ચાલુ કર
તો તમારો પાસવર્ડ
હજી કોન્ટ્રાક્ટ ઘટાડ્યો
આ રાઈટ નું કોર્નર જ જોજે ખાલી
અમે
નવો જ રાખો.
2024 થી 768 લગીનનું રિઝોલ્યુશન
આટલી ડીપ
ઓય યાર રાઈટ નું કોર્નર જ જો ખાલી આ બાજુનો ભાગ તો જેમ જ પ્રોબ્લેમ છે
ઘટાડવામાં દેખાય
મોટું સ્ક્રીન સર ને પાસવર્ડ બોલ ને પાસવર્ડ બોલ ને
ચાલે સર
સર તમારો પાસવર્ડ
પહેલા કરતા સારું છે.
એક મિનિટ હા હું જોઈન પછી કોલ કરું ઓકે
જોજે હા ઓવર આવે છે
હવે જો
સર હજુ બી આ કોર્નર પર તો ના દેખાય
એ બોક્સ કાઢી કોઈ ડાયલોગ બોક્સ કોઈ પણ બોક્સ પર કમાન્ડ ખોલ દેવો છે
ઉભા રહો
હા એ કમાન્ડ કી કોઈ પણ ખોલે
આ ભાગ જે છે ને એ નહીં વંચાતો બરાબર એટલે આમાં જ શું પ્રોબ્લેમ હશે કે ના ના બોર્ડમાં પણ નહીં પ્રોજેક્ટરમાં જ પ્રોબ્લેમ છે લેફ્ટ સાઈડ બરાબર છે આટલો ભાગ આખો આમાં જ પ્રોબ્લેમ છે
ભાઈ તું જોજે
નહીં દેખાતું
એક પેજ આટલું બકા સ્ક્રીન હશે નહીં ફિક્સ હોય હાથ વડે થોડું લોક મારેલો
આનું સેટિંગ આનું થશે ટીપ
ખબર હે તારા જેવા છોકરા હોય
આ બાજુ છે
એ જતું રહ્યું એ હાથ મૂકો તારા આગળની પ્રિન્ટ આવશે ને તો હાઉ ચાકુ થાય રોંગ રેવા દે. છે ને
ક્યાં
પર નહીં ભાઈ હાથ એડો મારો
લેન્સ પર ખાલી સાફ કરી દો
બંધ કરી
સો પણ નહીં આખામાં ફરક પડે આટલામાં તો કંઈ
લેન્સ પર ખાલી સાફનો
એનો પ્રોજેક્શન નું અલાઇનમેન્ટ નથી બરાબર એટલા માટે એ બાજુ જુઓ તારે વજે સ્ક્રીન નહીં રહ્યો ના ના આ બાજુ પરફેક્ટ છે
આ ખાલી આ કોર્નર પર
આમનું અલાઇનમેન્ટ
ભાઈ આવે છે આપણે
તો આનો પોતાનો પ્રિન્ટર પણ લઈ ફાઈલ નાખી દે આ બધું નાખી દે આજે હું લેપટોપ લેતો આવું ત્યાંથી કરી હા નાઇન કર દે નાઇન સારું નાઇન ઇઝ ગુડ નંબર ફોર ફિગર
રાઈટ સાઈડમાં જે પ્રોજેક્ટ થઈને આવે ને એ રિલેશન ખરાબ
નાઇન
લેફ્ટ સાઈડે સાફ આવે એમાં શું પ્રોબ્લેમ છે પાછળથી બીજો લેફ્ટ સાઈડમાં
ફેન
રિઝોલ્યુશનનો પ્રોબ્લેમ
એક જ ફોન
લોટ આવે લેફ્ટ સાઈડ
નવા પ્રકાર
ત્યાંથી કનેક્શન મીટર
હવે જેની જો લેપટોપ હોય ને એ લઈને આવજો મારી રીતે સોફ્ટવેર ઇન્સ્ટોલ કર્યા પછી નહીંતર આપણે લેબમાં 15 કોમ્પ્યુટર વર્કિંગ રહેશે એમાં તમારે
બાકી જાય
સ્વિચ ઓફ ના કરતો
લાઈટ કરો
હમણાં
ટાર્ગેટર
એ કરીએ હમણાં તો
મોહમ્મદ ક્યાં ગયો
સાંજે લઈ આવે ને
લેપટોપ છે
સાંજે લઈ આવે ને બધા
એવું નહીં એટલે એક કામ કરે પેન ડ્રાઈવ છે ને કે ઓય આ અપગ્રેડ પર બાર
ડાયરેક્ટ નાખી આપશું સર બધા સીડી આપ્યા કરતા મોસ્ટ ઓફ જોઈને પેન ડ્રાઈવ હશે
હા તો પેન
પેન
ડ્રાઈવ
ડ્રાઈવ
આપી
આપી
ના ના એવું નહીં પણ હવે ડીવીડી આજે તમારે
સર સોફ્ટવેર આપે ને અત્યારે ડીવીડી લઈ લઈએ એની અંદર બીજી વખત રાઈટ થાય ને એ રીતે ઓપ્શન આવે અંદર
ગવર્મેન્ટ સ્પોન્સરમાં મળતું હોય એવું બીજું
અને પેનડ્રાઈવમાં તો તારે પેનડ્રાઈવની જગ્યા તો રોકાય નહીં, પેનડ્રાઈવ તો બીજી આપવી ને.
અરે તું DVD લઈને લઈ લે. DVD લઈને પછી કોમ્પ્યુટરમાં કોપી મારી દે ને પછી આપણે તને એક સ્ટેટ પર ની અલગથી DVD નો પ્રોબ્લેમ સાચવવાની જ નહીં ખાલી. તમે એક તો કોણ છે જોઈએ તો જાણો
પેલું ડાઉનલોડ કર દો મિત્ર.
અહીંયા અમાર
આવી ગયા પેલા લંચ માટે.
દીપ આવી ગયા તો? શું? નયા લોકો આવી ગયા?
કેબલ કનેક્શન જે મૂકી રાખ્યું છે ત્યાં સુધી મળે.
હા તો
વાઈફાઈ એટલે સ્પીડ નહીં આવે.
આ બંધ કરી દઈએ. તમને આ સેશન બહુ ક્વિક જશે એટલે તમે કંઈક
બરાબર હતી બાકી આમ નાઇટલી વિડિયો બને તો આપણે કામ
હજુ તમે એકચ્યુઅલી સોફ્ટવેર પર બેસો ને તો તમને ખબર પડશે વોટ ઇઝ ધ પ્રોબ્લેમ. આમ તો આ તો 2-3 કલાકમાં તો ઊંચું મેલી દેવાય પણ પછી આવડે ને તો બરકત નહીં આવે.